Okay, hello everyone. Thank you for being here. I hope you're having a good time. My name is Jura Chung. I'm from Orchestra, and today I'll be giving you a brief presentation about our automation process for deployment, OpenStack deployment. Today's presentation would be about 15 minutes long. We're just going to be going through the different features of automation that we provide in our tool. We're also going to be giving you an overview of the possible benefits and insights, hopefully, that we could provide. So after the presentation, if you want to ask any questions or if you want to provide any feedbacks, please feel free to visit our booth. During the Marketplace Mixer, we're also providing beers and beverages as well, so please feel free to visit us there. So let's dive in. So before going in, I'd just like to give you an overview of the table of contents. So first, we're going to be talking about a background to give you a better understanding of what we're doing and to give you an understanding of the challenges that we've been facing as well. And then second, we're going to be talking about the needs to why automated deployment is necessary in the perspective of optimization and efficiency. And then lastly, we're going to be talking about the different areas of automation that we provide and how we are providing them. So the technical level of the presentation wouldn't be so deep, but hopefully it provides you a good overall insights to how and the tools of automation that we're using to provide these services. So first, who are we? Okeestro is a software company based in Seoul, South Korea. We provide a full stack of cloud solutions to our clients so that they could deploy their own cloud data center. We don't have our own data center, nor are we a cloud service provider. But our clients are probably they're major data centers within a conglomerate, so they're IT managers. So utilizing our cloud softwares, they're providing their IT services within their conglomerate. And so to go briefly about our full stack of solutions that we have, from the bottom layer, we have our OpenStack-based IaaS platform that we provide. We also provide Kubernetes native PaaS platform. And in the middle, we have our Orchestra CMP, which is our multi-hybrid cloud management platform that manages various wide range of cloud environments. So from VMware to Red Hat OpenStack to Mirantis, Nutanix, AWS, and GCP. So it covers quite large range. The purpose of the CMP is to provide integrated management and unified GUI for more simplified, efficient management of the various cloud environments. And I think it's a very unique need that we face in the Korean market. But yeah, it's one of the needs that we face. And so we have our own interbroker API management system within it that provides a unified way of managing the workflow. And above, we have the cloud service to optimize your cloud environments. So from data ops to DevOps for automated CI/CD, MLOps, and AI ops. So these are the full stack of solutions that we provide. And among these, we're going to talk about specifically our Contrabase, which is our IaaS solution. So first, let's talk about why automated deployment is necessary. In this diagram, you can see in the left side the manual processes that has to be taken through before automation takes place. So if there's a request for deployment, the infrastructure admin, they would have to communicate with various administrations from different areas. So from some servers, from network storage, to security administrations, you have to coordinate with them, and there's a complex process that's involved in it that takes manual work. And then after that, to deploy those systems, you need to have reliance on an OpenStack technology expert. So these processes kind of may produce bottlenecks, especially for clients that are using repetitive manual tasks. So instead of providing them those hardware and burden, we want to provide automation so that we could lessen these burdens and provide more efficiency. So let's talk about the benefits of automated deployment. So first, it increases efficiency by eliminating the need for manual repetitive tasks, as I already mentioned before. And it also reduces the chances of human error and variations in the configurations. Second, it increases consistency and standardization. So it decreases the chance of misconfiguration, as I mentioned before, and errors in the components of OpenStack in the way you want to deploy it and the way you want to structure it in the environment. And this, the simplification and the standardization, consistency of the architecture and the way you configure it, it kind of decreases the burden of operation. And third, it increases scalability and flexibility in your environment. So if your client would like to increase or like just scale up certain services, it's very simple for them. And it also enhances version control. So with utilizing IAC, infrastructure as a code, it improves the chances, it improves in efficiency in tracking your code and how you've been updating them. It also, OpenStack requires continuous management and updates to address, security patches, bug fixes, and feature enhancements. So with these automation tools and deployments, we provide a structured approach for managing these. And it simplifies the process by applying, updates and patches across the whole OpenStack component, even within the provisioning stage as well. And then lastly, it helps mitigate dependency on technical personnel. So even if you have a kind of hard time recruiting OpenStack expertise, it really just kind of decreases the burden in that area as well. So overall, OpenStack automation kind of deployment streamlines the initial deployment processes, improves efficiency, ensures consistency, and simplifies the ongoing operations within your cloud environment. So in which areas did we provide automation? So there's 3 areas that we provide automation in. The first is deployment, second is operation, and third is security. So in the deployment part, you guys may be very familiar with the deployment part. So we install and configure the OS into the host OS. So and deploy and provisioning OpenStack, integrating OpenStack with the wide range of hardwares and network and storages that you need, and providing high availability and clustering of the OpenStack components. Second, in the operation level, we provide self-server provisioning, and we provide virtual machine management through our internal port, and we'll be talking about why we use internal port in this area later on. We also provide live migrations and version patch upgrades, also monitoring as well. And then lastly, for security, we provide automated patching for CCE and CVE as well. We also provide self-signed certificate renewal for TLS communication and password change. And we also provide automated fault detection and fault recovery. And we're going to be going a bit deep dive into each area later on, but not too technically. So if you have any questions, please come visit us later on. So this is an overview of our automation. So if there's a request for a certain deployment for OpenStack or certain in different areas of automation, we use our MaaS, Ansible, and Terraform as our basic engine, and we use Jenkins to deploy them. We also have GitHub to kind of manage the updates and the configurations as well. And this is the automation layers, and we added this slide just to give you an idea of which automation tools we utilize in each layer of the deployment. So from the bottom layer, we utilize Canonical's MaaS to deploy hardware deployments on OS. And then in the middle layer, we use Ansible for the configuration of the hardware and software deployment and software configuration for OpenStack. And above in the virtualized layer, we use Terraform and Ansible together. And we're going to be going a little bit deeper later on in the slides. All right, so this is the overall architecture of our deployment system. So through our deployment tool, as you can see, we also not only provide deployments for OpenStack, but we also provide automated deployment for Kubernetes native environments as well. So you could deploy them either way. You could deploy the OpenStack above a Docker, but you could also deploy them on bare metal as well. But you could also deploy Kubernetes clusters on the bare metal directly as well through our automation. You could also, we provide OpenStack configuration file encryption for security issues. We also provide scaling up and down for the infrastructure. And if you look in the middle layer, so we basically use repository to manage these systems and to manage the metadata of all these automations and to provide version upgrades and patches as well. And as you can see, the result of the test will go through the reporting tool, and then we'll kind of automatically adjust the test variables and reconfigure them accordingly to deploy them in the way that we set them before. So this is basically an overview of what we do, and in the following slides, we want to discuss more specifically on specific areas. So I won't be covering the whole entire automation process, but so the OS deployment phase is basically fairly, simple, very familiar with you guys. So it's canonical. We're basically using canonical MaaS to provision the OS. So it kind of goes through 4 phases: the enlistment phase, the commissioning phase, and the deployment and the release phase. So to put it simple, in the enlistment stage, we identify the nodes that you want to deploy the OpenStack components to. And during this stage, you are kind of identifying which nodes are for which functions and purposes. So compute nodes and the control nodes, you're differentiating them there. In the commissioning, once you identify the nodes, you go through the commissioning process, so including network configuration and ensuring that the nodes are ready for deployment. And then in the deployment stage, you really just deploy the OS into the nodes. And then in the release stage, once the OS has been deployed, the nodes are released from the MaaS control, indicating that the nodes are ready to be used and utilized. So this, I think, is fairly straightforward. It's fairly simple. And then next is our OpenStack deployment stage. So each layer of automation is kind of in a separate function in itself. So it doesn't have to go through the whole process from bottom to top. It just kind of you could provide those functions, automated functions necessary to where you need them and when you need them. So as I already mentioned about MaaS, about the host OS provisioning, I'll kind of go over to the above stage. So basically during the first is you automate deployment for the host OS. Once the verification is complete, we use Cloud Init for automated OS tuning to enhance the host OS and OpenStack performance as well. And then we deploy the OpenStack components to the designated nodes, as I mentioned before, to whether it is compute or control. And then lastly, after the OpenStack components are deployed, our OpenStack automation performs testing to ensure that the cloud is fully functional. So that happens in the OpenStack deployment layer. So it would happen in this layer. So after your OpenStack components are deployed into the nodes that you have designated to, it goes through it uploads the template guest images and also applications to test if the virtual machines are functioning as the way that you want. And then it will kind of just release them again, just to test if there is any misconfiguration during the process. And this is the process for Orchestra automation for operation. We're going to be focusing our presentation more on this aspect. So from the bottom, you can see that we provide automation for emergency failover for the security purposes. We also provide configuration for encryption. And then we provide monitoring based on Prometheus and Grafana, so about the OpenStack host OS environment to ensure that it's running properly. And then we, as I mentioned before, we provide CVE, CCE patch. And then we provide virtual machine management through our internal port. And today, we're going to be focusing on 3 different areas about fault detection and fault recovery of the cloud services for our database service. So first, let's talk about our fault detection and recovery. So it provides automation for emergency failovers. So in case there's a failure within the nodes, our OpenStack automation tool would naturally find an idle host and kind of go through the same phase as before for the OpenStack deployment. So they would deploy the OpenStack components into the idle nodes, and then they will live migrate the virtual machines that was running on that system to the idle host. And then using MaaS tool, we're going to delete and release the host OS from the failed host and node. So this is basically a function that was really necessary in some of our clients' environment when they need to have service continuity, service security as well. And then next is we're going to talk about fault detection and recovery. So our fault detection and recovery is focused on the cluster service with a RabbitMQ, Percona, and Pacemaker. So these services are basically a single service for database to provide high availability and scalable database services within our OpenStack. But as you may already know, RabbitMQ is one of the services that has a lot of errors, that has a lot of faults in it. So it was very important for us to kind of focus on providing automated fault detection and recovery in this aspect. So we provided that. Our automation is in the background. We use IAC tools for it. So yeah, basically we provide that area. And then we also provide management through our internal port. And the reason why we're using our internal port is to decrease the unnecessary use of resources through positioning the management in a separate virtual machine. So yeah, most clients, and it's very specific to the needs that we faced in the Korean market. So because of the government regulations and policies, they have to manage the IPs of regularly. But with the expansion of IPs that they have to manage, it becomes more difficult in the operation aspect and the administration aspect. So to enhance their efficiency, we decided to use the internal port instead. So internal port to manage those systems. Not just in the IP management perspective, we also provide the management for deploying and provisioning the services. So as I mentioned before, all of our services are pre-configured. So our virtual machine sizes and the applications that will that's deployed, provisioned within the virtual machines are already pre-configured before within our automation tool management. So through the internal port, you're just kind of provisioning these images through the virtual machine as requested by the users. And lastly, I kind of wanted to touch on why we use and utilize our repository rather than image-based or other thing. It's because it provides a wide range of compatibility for hardware, SDNs, and storages. And because our clients are major, they provide vast range of services to their conglomerates within. They have a lot of different hardwares. They have different SDN environments. They have a lot of different storages that they need to plug into automation. So we use plugins to automate the compatibility within the environment. So when you're deploying the OpenStack components through our IAC code in the backend, you recognize the different hardwares, and through plugin and repository, you kind of automatically are synced in to the system as a whole. So it's kind of lessens the burden of the whole process of manually integrating the different systems. And this is basically just the 3 major compatibility map for our servers and the different functionalities that is automated behind in the backend. So Dell, Fujitsu, HP for OS provisioning, server virtualization, GPU, SRIOV. They're all pretty much pre-configured in our backend so that it's automated to be synced, integrated to these hardwares. And then we have a vast range of hardware storages that is automatically configured so that it's integrated through plugin. And as you can see, it's just you could look over it, and then if you have any questions, please feel free to ask. And then lastly is SDN. So network has been a big issue in Korea as well. So we have integrated them a lot with the various SDNs through our portal. So our portal pretty much enables management of these SDN environments integrated to our OpenStack platform. So yeah, and these are the functionalities that we provide through our portal as well. So with this, I'll kind of wrap up my presentation. If you have any questions or any feedbacks regarding the presentation or the content, please feel free to visit us at our booth. Thank you so much. Also, it's our first time at a global summit. So if it's possible, would you like to take a picture with us in the front real quick before we kind of go? Would it be okay?
Please. Please, it's our first time.
Okay.
Yeah.
If you're more willing to. Oh, thank you so much.
Thank you. getting treated. You guys, yeah, reference, yeah. Please, yeah, please. Thank you, thank you, thank you. So nice, thank you.
Would it be possible if we have the screen up, our front screen?
Thank you, please.
Thank you so much.
Yeah, I
완전 엔지니어 같아.
대표님 표정이 안 좋아서 개쩔었잖아. 잘했어.
사실 일 뭐 약간 다른 일 좀 있어가지고.
Would it be okay if we like people in the middle? Thank you so much for coming and
누가 찍어줘야 되나?
뭐 찍어줘야 되는데? 잠깐만 좀 진짜. Yep. Thank you.
Cloud.